Business rules specify the required state of behavior of IT systems and typically involve deontic constraints that focus on the permitted actions, obligations, and prohibitions of the system agents. In this paper, we present a proposal to explicitly specify dynamic deontic constraints in UML and OCL so that, on the one hand, they can guide and restrict the system behavior, and, on the other hand, allow us to reason about such deontic behavior, including accountability analysis. This is a joint work between the University of Bremen and the University of Malaga. To illustrate our work, let's suppose the borrowing process of a book in a library. The structure of such a system can be modeled by instances of librarians, users, and books, and a holding relationship that indicates the agent that currently has the copy of a book. The behavior can be modeled by actions, such as borrow, that changes the state of the system, in this case by changing the holder of the book. In addition, integrity constraints, both structural and behavioral, impose restrictions on the system, i.e. the duration of loans. They define the policies or business rules of the system. In this work, we are interested in the specification of those constraints, especially the behavioral ones. To do this, we need to differentiate between alethic and deontic constraints. The former ones specify hard or physical constraints that must always hold. In turn, deontic rules specify constraints or obligations that can be violated or can even change over time. For instance, a book could be returned later than it should be. The deontic constraints deals with these issues and describes behaviors instead of permissions, in terms of permissions, obligations, and prohibitions, what we should do and what we should not, what we are allowed to do and what we are not allowed to do. In addition, accountability analysis permits identifying who's responsible or liable for what and who to blame if things go wrong. There are already proposals to specify deontic rules in software systems, and even standard notations such as the OMG's Semantic of Business Vocabulary and Rules, SVBR, or the Object Role Modeling, ORM, or the ODP Enterprise Language. They have proved to be useful in particular domains, such as e-health. They normally use modal logics and declarative specification approaches. The problem with these approaches is that they require specialized knowledge, skills, and tools, which are not very common, especially when compared with the knowledge, skills, and tools available for static analysis of software specifications. Our work aims at addressing these drawbacks by allowing modelers to specify deontic constraints and rules in plain UML and OCL using an operational style instead of a declarative one, based on two main pillars. A, the verification of deontic permissions and obligations as objects, which are assigned to the system agents, and B, the verification of actions as objects that link their correspondence before and after system states. Thus, a film strip is a sequence of models, snapshots, linked by the actions that trigger the system changes. In this way, behavioral constraints become structural invariants in a film strip. To show how our proposal looks like, suppose a student grading system with students and teachers. Students register with teachers and produce reports, which should be graded by the corresponding teachers. Once a report is graded, the student can see the mark. A possible specification using the tool use is shown in the screen. Examples of deontic constraints for that system include those that determine when a student is permitted to register with a teacher, the obligations that both the students and teachers acquire, and the actions that are permitted to perform. For example, students are permitted to register with any teacher who does not have a report from them still pending to grade. Once registered, a student should deliver the report and the teacher has the obligation to mark it. The students can see their marks, but not the marks of other students, for instance. In our proposal, we use film strip models. They are fully implemented in use. That is, given a class diagram with operations and a sequence of interactions defined by a sequence diagram, you can obtain a film strip model with a sequence of operations and the corresponding state changes. In this case, we can see a sequence of 5 actions, which were those in the sequence diagram showed before. Then student Harry registered with the teacher, Snape then delivers a report, the teacher grades the report, and then Harry sees his mark. We can see how the same film strip now with deontic tokens, that is, burdens and permits added, and how they evolve. We can see how objects discharge burdens after completing actions and acquire new burdens and permits too, which should be discharged later. The main value with our proposal is not the fact that we can specify Deontic constraints using film strip and Deontic tokens. It is the kind of analysis that we can accomplish with this specification. In particular, we can perform simulation and static analysis on them. First, our proposal allows two execution modes, one by selecting a sequence of actions and executing them in order to see whether they fulfill the invariants, and another where we allow the system to select any of the possible actions that are enabled until no further action can be performed. Secondly, we also allow different kinds of analysis on the system specifications, such as temporal or reachability analysis, constraint independence, or accountability analysis. The paper contains the description of all these analyses, but let us briefly illustrate here two of them. For example, we can check whether a sequence of operations is valid or not according to the Deontic rules. In this case, a student registers with a teacher, then he delivers the report is graded, followed by a sequence of views by the teacher or the students in no particular order. This constraint can be simply specified as a static invariant on the field string and as shown there. More interestingly, we can employ the use model validator to automatically find valid behaviors, that is, film strips, that starting from an initial configuration can lead to a given state, which is specified by another invariant. The paper contains more types of analysis and how to conduct them automatically with use. To conclude, our work has focused on the explicit representation of the Deontic rules using an operational style of a specification that enables different kinds of analysis using static approaches and tools. The use of Deontic tokens also permits the separation of concerns between the alephic constraints, which are immutable, from those that can change or evolve over time. Regarding our future work, we keep on experimenting with our proposal with more case studies. We also plan to specify delegations of permits and burdens, something that incorporates an extra level of difficulty because a delegation is also an action and therefore it may also need permissions and burdens. So far we have used a pessimistic enforcement model whereby permits are required to perform actions. This may require too many explicit permits in some cases. An optimistic enforcement model based on the explicit prohibitions need to be studied and compared with our proposal, deciding when it's better to use one or the other. Finally, we also plan to study the possibility of defining mappings to and from other modeling notations such as SVVR or the object role modeling. Thanks for your attention.